Okay, now again, here's our law. And we have the same particle moving along the x-axis with the same velocity as in the very first problem. So the QV is negative 4.8 times 10 to the negative 13th amp meters times the I vector. Now, we want to calculate the field at the point 0, 10 centimeters, 0, the way it's given in the document. And that's, of course, a point 10 centimeters out along the y-axis. And we want to calculate the field when the particle is at the x-axis. So we want the field at 0, 10 centimeters, 0, and the particle is at the origin. So here's our QV vector, and I've drawn that, with its root at the origin, but it could be anywhere out along here if you want to do it that way. But here's our QV vector, here's our point, and here is the R vector from the location of the charge to the point at which we calculate the field. Okay, and we want to calculate the field here. Now we could calculate the field anywhere, but for the moment we're going to calculate it here. And of course we have a convenient situation here where we've got a right angle between the QV vector and the R vector. And since we're taking a cross product, that's going to be very handy. We're not going to have to worry about a sine of theta. It's going to be 1. So we're just going to find the magnitude by multiplying all these magnitudes and dividing by r squared here. So the R vector is 10 centimeters times the J vector. Okay, it goes from the origin to the point 0, 10 centimeters, 0, which is right here, 10 centimeters out along the y-axis. And then our R hat vector, now go ahead and use that R hat notation, which is the unit vector in the direction of R, is just the J vector, and that's very clear. Of course, we could formally divide the R vector by its magnitude, which is 10 centimeters. What happens? 10 centimeters divides out, and we're left with J. So we can do the calculation formally, or we can just see that any vector in the J direction is going to have a unit vector that's equal to J. Okay. Now, the magnetic field I've got drawn here, but let's think about this. Okay, QV is in this direction, the negative x direction. In order to turn QV toward the R vector, I'm going to have to put my hand this way so I can turn it, and my thumb is going to point straight down, so that the B vector is going to be in the negative Z direction. So here it is. Now that is the end of what we were able to do in class, but of course I expect you to go on with that, so I'm going to do just a little bit more in a couple of optional videos.